Well, this is the next program. See it? Write a Java program to sort the contents of an integer array in the ascending order by using selection sort, it seems. By using selection sort. And of course, one note is also given. What is a note telling? The selection sort statements has to be kept in a method called as selection sort. Means you have to write that selection sort algorithm statements, probably in the selection sort method only it seems, which would accept an integer array as a parameter and would return void. It would return nothing. Well, this is the question. Let us write a selection sort method. Let us keep the statements of doing selection sort inside that method. First, we should know what is selection sort and how the selection sort would work. That only we don't know. Bubble sort we have learnt previously. There only I have told you that sorting is the process of arranging the elements either in the ascending or in the descending order. That using bubble sort we can do. Now they are asking to arrange the elements in the ascending order using selection sort. If you will ask me, sir, what is selection sort and how the selection sort would work? Like this it would work. Say supposing I have few elements in an array like this, 86, 42, 23, 18 and 25. These are the elements present in an array A. Let the name of the array be A. I would give off the name to all the arrays that I have made ready like this. Okay, sir, 86, 42, 23, 18, 25 we have. Next what? Correctly look at the elements and tell me, are they in the sorted order? Certainly not, they are not in the sorted order, or they are not in the ascending order. Ascending order, sorted order, both are same. Are they in the ascending order? No, they are not in the ascending order. You have to arrange them in the ascending order by using selection sort. If you ask me, sir, that only, how should we arrange it? By using selection sort. Like this, watch it. Initially, you have to start from I equals to 0. Listen to the algorithm carefully. Listening makes you a better coder. Start with I is equals to 0. And assume whatever is there in array of I, that only has a minimum element. Look at it. Assume, again assumption is what you have to make it seems. Assume whatever is there in array of I, that only has minimum element. I is 0. What is array of 0? 86. We have to assume that 86 itself is the minimum element it seems. That only is the minimum it seems. Actually that is not, but assume is what they are telling. Okay. Next what, sir? Its position. Which position, sir? 86 position. What is 86 position? 0. Who is handling 0? I. Its position that is present in I, give it to a variable called as POS. POS means position. That is what you have to do initially it seems. No rocket science I did. I have an array inside that full integer elements I have in the random order. So what I did? I made I to point to 0 and whatever is there in array of I, that only I thought it as minimum, I just assumed it as minimum, and its position, 86 position which is present in I gave it to POS. Okay sir, next what? Appoint one servant called as J, one step ahead of I like this. Look, appoint one servant J, one step ahead of I was 0, J is one step ahead of I, J is 1. Okay sir, why we should appoint one servant called as J one step ahead of I? To search for the real minimum. What did we do? We just assumed whatever is there in array of I, that only has minimum. But is that the real minimum? 100% not, we also know. Who is the real minimum then? For checking that only, appoint one servant called as J, one step ahead of I. After appointing, check whether array of J is less than minimum or not. Always remember, when I tell minimum, you have to look at here. Don't look at off here. Whenever I tell minimum, you have to look at here because minimum is here only. I have written minimum here. So once you appoint servant to check for real minimum, now check whatever is there in array of j, whether it is less than minimum. What is array of j? 42. What is minimum? 86. Is 42 less than 86? Yes. If array of j is less than minimum, take that array of j. What is array of j? 42. Take it. Give it to minimum. 42, give it to minimum. Its position, 42's position, which is handled by j, whatever is there in j, give it to POS. 42's position is 1. Okay, sir, next what? Did we get off the real minimum? Who knows? Many other elements are there. Real minimum might be ahead. So continue searching. J++, move j ahead. Again check whether array of j is less than minimum. What is array of j? 23. What is minimum? Look at the minimum. 42. Whether array of j is less than minimum, is 23 less than 42? Yes. If it is less, then take that array of j. What is an array of j? 23. Take it out. Give it to minimum. Its position. What is 23's position, which is present in j? 2. Give it to POS. Given. Did we find the real minimum? Who knows? We really don't know. Still elements are there. Move ahead. Search it. Move j ahead. Again check whether array of j is less than minimum. What is array of j? 18. What is minimum? 23. Is array of j less than minimum? Yes, it is less than minimum. If it is less than minimum, take array of j. 18 you take it, give it to minimum like this. Its position. What is 18's position? 3. Give it to POS. Its position which is present in j, give it to POS. Did we get the real minimum? Who knows? We really don't know. Move ahead. Your duty is to check. So move ahead and check. Again check. Is array of j less than minimum? Is it less than minimum? What is array of j? 25. What is minimum? 18. Is array of j less than minimum? No, it is not. If it is not, you simply move ahead. If it is minimum, if it is less than minimum, then take that and give it to minimum. If it is not, don't worry, just move ahead. If you will move ahead, no other element, j has fallen down from the array or j has surpassed the boundary of the array. If j will surpass the boundary of the array or if j will fall down from the array pictorially, whatever is there in array of I, look at I, where is I? Here. Whatever is there in array of I and whatever is there in array of position. What is position? 3. What is there in array of position? Array of 3, 18. Whatever is there in array of I and whatever is there in array of position, swap it. I repeat, once j falls down from the array or once j goes out of the boundary of the array, take whatever is there in array of I and take whatever is there in array of position and swap it, exchange it. If you will exchange, then look at it. 18 will come here, 86 will go here. That is what is exchanging. Look, I have exchanged. The remaining elements is untouched. 42, 23, 25. By the end of first iteration, we have selected the first minimum element. Look at it. We have selected the first minimum element and we have given its position in the ascending order. If these are the numbers, what is 18th position in the ascending order? This only. So we have selected the first minimum and we have given its position. Okay, sir. Next what? What is I value previously? 0. Now I value will be 1. I value will be 1. Okay, sir. Next what? Repeat. Whatever is there in array of I, that only you assume it as minimum initially. So minimum now is actually 42. Its position which is present in I, give it to POS. Okay, position is 1. Really, is that only minimum? We don't know. We have to search the array and check the real minimum. For that purpose only, I will appoint one servant one step ahead of I. Look at it. J will be one step ahead of I. Because from there only searching has to be done. Okay, sir. Next what? After appointing, check whether array of J is less than minimum. Minimum is 42. Array of J is 23. If it is minimum, take array of J, give it to minimum. What is there in array of J? 23. 23, give it to minimum like this. Its position which is present in J, give it to POS. Don't stop. You really don't know whether which is minimum, correct minimum. Move ahead. J++. Now check whether array of J is less than minimum. Is 86 less than 23? No. If it is not, don't worry. If it is, then only give. Otherwise, leave it. Just move ahead. Okay. We'll move ahead. Again, is array of J less than minimum? No, 25 is not less than 23. If it was less, you would have taken. But it is not less. You move ahead. If you move ahead, J is going out of the boundary of the array or J is falling down from the array. If J goes out of the boundary of the array, what should you do? You have to take whatever is there in array of I and whatever is there in array of position and you have to swap it. If you will swap whatever is there in array of I and array of position is 2, array of 2, this 2 if you will swap, then 23 will come here, 42 will come here. Look, I have swapped. Other elements is untouched. 18, 86, 25 is untouched. Now if you see, we have actually taken the second most minimum element and we have given its position in the array. Okay, sir. Next what? I previously was 1. Now I will be 2. Again assume that whatever is there in array of I, that only has minimum. What is there in array of I? 42. That only is minimum. Its position that is present in I, that you have to give it to position. Okay, sir. Next what? That only is real minimum? We don't know. So I will appoint a servant called as J one step ahead of I to check for the real minimum like this. J will always be one step ahead of I to check for the real minimum. Once you have appointed the servant, check whether array of J is less than minimum. Is 86 less than 42? Certainly not. Move ahead. Check for the real minimum. Again check whether array of J is less than minimum. Is 25 less than 42? Yes, it is less. If it is less, then take array of J, give it to minimum. Its position that is present in J, give it to POS. Did we complete? Move ahead. If you will move ahead, J will go out of the boundary of the array or J will fall down from the array. If J goes out of the boundary of the array or if it falls down from the array, what you have to do? You have to swap. What you have to swap? Array of I and array of position. Array of position, these two you have to swap. If you will swap, then look at it, 25 will come here, 42 will go there. Remaining elements 18, 23, 86 is untouched. Now if you will carefully see, we have taken the next minimum element or we have selected the next minimum element and we have given its position. I previously was 2, now I will become 3. Whatever is there in array of I, that only you have to assume it as minimum. Again, just an assumption. Initially, assume it. Its position that is present in I, give it to POS. Appoint a slave or appoint a servant one step ahead of I, called as J, to check for real minimum. Now check whether that is minimum or not. Is array of J less than minimum? Yes, it is less than minimum. If it is less than minimum, take array of J and give it to minimum like this. 42, because that is what is array of J. 42, give it to minimum. Its position that is present in J, give it to POS. Move ahead, because still we don't know whether that is minimum or not. Move ahead. If you will move ahead, j will fall down, or j will go out of the boundary of the array. If j goes out of the boundary of the array, what you have to do? Take whatever is there in array of I and take whatever is there in array of position, and you have to swap it. If you will swap, then look at it. 42 will come here, 86 will come here, 25, 23, 18 is present there. If you will carefully see, one more minimum element we have selected and we have given its position in the array and stop it. Why, sir? Why? Because there are 5 elements. 4 elements place we have given, means 5th element will occupy its position directly. So stop it. Now you see the elements in the array. 18, 23, 25, 42, 86. Initially what it is? 86, 42, 23, 18, 25. We are successful in arranging the elements in the ascending order. Now whatever you are seeing here, this is how your selection sort algorithm would work. Logically like that you can think when to stop, or you only see, if I will continue, I is 3, I is 4, I would continue. Next what? Whatever is there in array of I, that only you think as minimum. Okay. Its position you give it to pivots. Okay. Next what? Appoint a servant one step ahead of I. What is there one step ahead of I? Nothing is there. Logically also I have told you. Algorithmically also I have told you why you have to stop. Logically 4 elements we have sorted. One element is automatically sorted. Or if you want to continue the algorithm, how will you continue? No other elements are there. So stop it. Now let us understand some facts and write the algorithm. Let us understand some facts. Look at it. How many elements are there? 5 elements are there. If n is 5, I repeat, if n is 5, I started from 0 and I went until 3. 5 is the number. I started from 0, went until 3. So 5, 3. If I is 6, it would have gone until 4. If I is 10, it would have gone until 8. If I is 100, sorry, if number of elements n is 100, I would have gone until 98. Am I not correct? If n is 5, it went until 3. If it is 6, it will be 4. If it is 10, it will be 8. If the number of elements is 100, it would have gone until 98. So in general, if I have n number of elements, I will start from 0, it will go until n minus 2. Look at it. If n is 5, I will start from 0, it will go until n minus 2. Okay sir, next what? In every iteration we are doing something. What we are doing? We are taking whatever is there in array of I as minimum, its position as POS. And then we are starting j from one step ahead of I. Look at it. J from one step ahead of I. J from one step ahead of I. J from one step ahead of I. So always j is starting one step ahead of I and j is going until last. If you see, wherever it is, j is going until last. Once it is going away of the last or out of the last, then we are doing something, forget about it. But j is always starting one step ahead of I and going until last. By keeping these two in our mind, I is starting from 0, I is going until n minus 2. J is starting one step ahead of I and j is going until last. By keeping these two in our mind, shall we write algorithm? Whatever we have done diagrammatically, the same thing I would write it probably in the pseudocode format. Look at it. This is what selection sort algorithm tells. If n is the number of elements, then start I from 0. Go until I less than or equals to n minus 2 every time I plus plus. What did we do initially? Nothing great we did. Whatever is there in array of I, that only we thought as minimum, that only we assumed it as minimum. Its position that is present in I, we gave it to POS. That is what we did. Look. I started from 0. Whatever is there in array of 0, array of I, that only is minimum, its position to POS. I became 1. Then also whatever is there in array of I only, we gave it to minimum, its position to POS. I became 2. Then also whatever is there in array of I, that only we gave it to minimum, its position to POS. So ultimately, Start from I to 0, go until n minus 2. Every time, whatever is there in array of I, that only you think as minimum, its position, give it to POS. Did we stop there? No. After assuming the minimum and its position, we appointed a servant. One step ahead of I, correct? Same thing I would write. Look at it. Now, appoint to one servant called as J, one step ahead of I plus 1. That is what is one step ahead of I. Go until J less than or equals to n minus 1. Correct. Last, if n is 5, J is going until 4. So n minus 1. Start from I plus 1, go until n minus 1. J plus plus. Every time what are we doing? We are checking whether that array of J, is it less than minimum? This is what we are checking every time. If array of J is less than minimum, then what did we do? We just took whatever is there in array of J and we have given it to minimum. Its position that is present in J, we gave it to POS. Sir, if it is not minimum, if it is less than minimum, we gave. If it is not less, sir, if it is not less, simply we moved ahead J plus plus. By chance, if J falls out of the array, means if J becomes greater than n minus 1, like this. If J becomes greater than n minus 1, if J becomes greater than n minus 1, if J becomes greater than n minus 1, then I have to swap. What I have to swap? Whatever is there in array of I with array of position. That is the opening of the for, this is the closing of the for. Done. Control coming out of this for loop means J is falling down. Both are same only, no? J is going out of the array index, or control coming down or control coming out, both are same. Because when control will come out of this loop, whenever J becomes greater than n minus 1. Whatever you are seeing here, this only is selection sort algorithm. Very simple. See how simple it is. If you will not know working properly and see that, it will be probably, oh, what is this? But if you will know this working, start from I equals to 0, go until n minus 2. Whatever is there in array of I, assume that only as minimum, its position give it to POS. Appoint a slave called as J, one step ahead of I, go until n minus 1 for searching the real minimum. If array of J is less than minimum, then give array of J to minimum and its position to POS. If it is not minimum, go ahead. Until when? Until you fall down of the array, until you go out of the boundary of the array. If you go out of the boundary of the array, swap array of I and array of position. Like that, if you will do from I equals to 0 until n minus 2, by the end of the array, if you will see, array would be sorted. I hope I am completely clear about the selection sort algorithm. First, copy this program as it is. Copy this working as it is. Then copy the logic as it is. We will have to convert this logic to the working program. That is still pending. So, copy this, then copy this. We will convert it to program. Be very quick. I hope you have completed it. We will convert that logic to the working code. So carefully watch it. Directly, I would start writing the class called as sorting. Inside the class sorting, what did they tell us? You have to write a method called as SelectionSort, correct? Which should return nothing, which should accept an integer array as a parameter. Well, same thing I would write. Watch it. I have one method which would return nothing and which would have a name called as SelectionSort and which would accept one integer array A as the parameter. Done. A is an array of integer, it is integer array A. That is what would happen. Okay, sir, next what? Very, very simple. Someone will take the array content, someone will pass that array to this fellow. He has to sort it in a selection sort way. How you do it? Like this. Watch it. You need one variable called as minimum. Am I not correct? you need one variable called as position. Am I not correct? And you have to start the algorithm like this. Start from I equals to 0, go until I less than or equals to array dot length minus 2. You tell n minus 2 or array dot length minus 2, both are same, no? Where n is the number of elements, array dot length is number of elements, minus 2. I plus plus. Every time whatever is there in array of I, think that only as minimum. Its position which is present in I, give it to POS. Will the program stop there? Certainly not. Real minimum you have to find. For that, we will appoint one servant called as J, one step ahead of I. We will make J go until array length dot minus 1 J plus plus. Every time we are checking if at all this array of J is less than minimum. If it is less than minimum, whatever is there in array of J, I am giving it to minimum. Its position which is present in J, I am giving it to POS. That is what I am doing. Say supposing I come out of the for loop, means J has fallen down. If J goes out of the boundary of the array, or if J falls down, if J becomes greater than array length dot minus 1, what I have to do is I have to swap array of I and array of position. For swapping, you know, I need one helping variable. So that also I would declare int help. I have to swap array of I and array of position. So what I will do, whatever is there in the first memory location, I would give it to helping memory location. Whatever is there in the second memory location, I will give it to the first memory location. Whatever is there in helping memory location, I would give it to second memory location. This is how you swap the contents of two memory locations. I have swapped array of I and array of position by using helping variable. That is the opening of the for, this is the closing of the for. By the time both these loops get executed, array content should be sorted. That is the opening of the method, this is closing of the method, that is opening of the class, this is closing of the class. Now if I want to make this program work, main method should be there. In the main method, all the inputs have to take, give the array to this fellow, he will sort it in the ascending order. How all this would happen? Like this it would happen. Carefully watch it. Possibly, I will write one more class called sorting app. Inside this class called as sorting app, I will write the main method, public static void main, which would accept string of args inside the main method. Inside the main method, I would create the object of scanner like this, scanner. Scan equals to new scanner of system.in. Next, I would ask the user, I would tell system.out.println, enter array length, I would ask. By seeing this message, the user will enter the array length. I would collect it by telling scan dot next int, and I would store it in a variable called as n, which is of type integer. Array length is there, array is not there. So what I will do is I will create one array by telling I need a new integer array of length the user has entered and present in n. Array would be created. I will collect that reference in ARR, which is of type integer. ARR is an array. I have the array, empty array of user length. I have to fill in the elements. So I will ask the user only like this, system.out.println, enter array elements. By seeing this message, the user will enter the array elements. I have to collect it like this. Carefully watch it. I would tell start collecting the input from 0th index. Go until array dot length minus 1 I plus plus. Every time tell system dot out dot println what to print, enter an element. By seeing this message, user will enter an element. I will collect it by telling scan dot next int and I would store it in array ARR of ith index. You know, by the end of this loop, complete array would be filled with elements. 86, 42, 23, 18, 25. Array is ready, in that elements are also there. Now I have to sort it. Before sorting how the elements should be there, I will print it off like this. System dot out dot println array contents before sorting. How it is? Like this it is. Start printing from 0th index, go until array dot length minus 1 I plus plus. Every time system dot out dot print what to print, array of I plus 1 space. Printing is also done. Now because I am using print, cursor has to come to next line because few other things I would print. I will bring the cursor to next line by telling system dot out dot println. Cursor came to next line. Now I have to sort it. For sorting I need not write logic again. I have already written this method does sorting only by using selection sort way. That is what it does. So what I will do is I would call that method. Before calling that method, I have to create the object of sorting. I would tell sorting. S is equals to new sorting. And I would tell S dot selection sort. Like this I would tell selection sort. Now I have to send the array for sorting. Array is there in ARR. I would send ARR. Carefully watch it. ARR will have the address of the array. Everyone knows it now. Array is an object. Object would be created. That address would be stored in ARR. In that array only you have stored the elements. Now you are sending ARR. The same array's address the control will take and go here. A would collect that address and start referring to the same array where ARR is referring. That array only would be sorted. Clearly that array would be sorted. After sorting I have to print it. Okay sir, how to print? Like this. Watch it. System dot out dot println array contents after sorting. After sorting how it will look? Like this it will look. Start printing the array from 0th index, go until ARR dot length minus 1. I plus plus. Every time system dot out dot print what to print, whatever is there in ARR of I plus 1 space. This is the closing of the for, that is the opening of the main method, closing of the main method, opening of the class, closing of the class, work is over. Now read the question again. What the question tells? Write a Java program to sort the contents of an integer array in the ascending order by using selection sort algorithm. You have to write the statements of the selection sort in a method called as selection sort, which accepts an integer array as parameter and would return nothing. I have written. If you will see the entire program, the program might appear big, it will have so many for loops and all. But if you will know the way of the writing program, everything is very, very simple. I have bifurcated the logic, selection sort only separately, taking the input, giving the input to selection sort only separately. In the main method I have did. This is how you have to code. This is the standard way of coding. Every task you have to keep it inside a method. Input you have to take from the main method, give it to that method to perform the task. That is why the definition for method also came. Methods are the set of statements used to perform a particular task. That is what I did. Now you know the selection sort algorithm also, you can implement it. Taking the input and giving to this algorithm so that it performs sorting also you know. Will it work? Might be your question. open the Eclipse, type the same program. See, this is a sorting class in which I have that selection sort code. Probably you have the sorting app class in which I am taking the input, creating the array, taking the input into the array and asking the selection sort to sort. I would right click, run as Java application. Look at it. It is asking for enter the length. I would enter 5 only, 5. Enter an element 86, 42, 23, 18, 25. As soon as I click on enter, array elements before sorting, sorting would happen, array elements after sorting, everything would be printed. Enter. Like this, the elements would be sorted. I hope I am completely clear about the selection sort algorithm, converting that algorithm to program. I hope I am clear. Copy this as it is. Copy this session. We will be stopping it here. We will meet you in the next session. Until next session, please do take care of yourself. Happy coding and